It's the atomic revolution, as seen from the vantage point of this 1957 book. I'm going to read you this bedtime story and show you pictures from the book while I do. Let's start with the book's short introduction. The people of the world are embarked on a period in their history that can most appropriately be described as the Atomic Age. The herald of the Atomic Age was the atomic bomb, forerunner of the hydrogen bomb, the most destructive instrument yet devised by man. The hope of the Atomic Age is the atom for peace, which holds out the promise of being the most constructive instrument of man's inventiveness. The problem of the Atomic Age is to contain the destructive power of the atom and at the same time to release its power for good. To the principle that to know is to understand, and that to understand is to act with wisdom, this book is dedicated. Gordon Dean, former chairman, United States Atomic Energy Commission. And here it says, Dawn. Boy, if that's dawn, I'll bet today will be a scorcher. It says, at 5:30 a.m., July 16, 1945, a blinding white light burst from a steel tower near the little trading post town of Alamogordo, New Mexico. The tower vaporized, and the sand beneath it fused into glass. Over mountains and mesas, thunder rolled and rumbled. A cloud, unlike any ever seen before, mushroom-shaped and many-colored, boiled upward over 7 miles high. The energy that lights the sun and the stars had been released on the planet Earth. This was the first atomic explosion, the dawn of the Atomic Age. Okay, well, comforted by the way this is going, I am not. Still, in the name of science, we'll press on, and so turning the page, we are going to learn about the pioneers. The Atomic Age had its beginning in the cold, wet winter of 1896. In his Paris laboratory, scientist Henri Becquerel made a startling discovery. By chance, he left a sealed, unexposed photographic film near a piece of uranium ore. Later, he was astonished to find the film darkened, as if by exposure to light. Studying the film, he concluded that it could only have been darkened by an unknown kind of energy, which he called radioactivity. Soon afterward, Pierre and Marie Curie discovered that radium was also highly radioactive, but could not explain why. Then, in 1905, Albert Einstein suggested a radical answer. Radioactivity is matter gradually changing into energy. Despite Einstein's revolutionary suggestion that matter can be changed into energy, scientists continued to believe that atoms, of which all matter is composed, are indestructible. But in 1919, Rutherford of England, working with rays emitted by radium, disintegrated an atom of nitrogen. His experiment did not show, however, that energy had been released. Einstein's belief was still theory. Finally, in 1932, an Englishman, John D. Cockcroft, proved that the destruction of atoms did in fact release energy. 2 years later, Irene and Frederick Joliot-Curie found that exposure to radiation also made other substances radioactive. And in America, only 11 years before Alamogordo, E.O. Lawrence invented the first large atom-smashing machine, the cyclotron. Well, this is going swimmingly. It looks like nuclear annihilation is just around the corner, or around the next page anyhow. Then, in early 1939, news came from Berlin that two Germans, Hahn and Strassmann, had split the uranium atom. Shortly before, a woman scientist, Lise Meitner, had fled from Berlin to Denmark to escape Nazi tyranny. It was she, working with another refugee named Otto Frisch, who first proved that the splitting of uranium atoms could release enormous amounts of energy. They called this new process fission. Within days, Niels Bohr of Denmark brought news of uranium fission to scientists in the United States. On September 1st, 1939, Hitler's Wehrmacht moved into Poland. Amid reports that the Germans were expanding their studies of uranium, the United States government began a program to determine the possibilities of atomic energy. At 7:30 a.m. Sunday, December 7, 1941, Japanese planes blasted Pearl Harbor. The United States went to war on the battlefronts and in the laboratories. As atomic research was stepped up, the Army established a secret organization, the Manhattan Engineer District. Its mission, to develop and produce an atomic bomb as fast as possible. 1 year later, Enrico Fermi and his co-workers at the University of Chicago started and successfully maintained a fission chain reaction in a pile of uranium and graphite. This was the world's first nuclear reactor. It proved the atom could be used for war or for peace. Yeah, well, that's nice. But what it didn't prove or show was what we were going to do with the nuclear waste that stays dangerous for thousands of years. We're still waiting for the answer to that one. Fission and fusion. Potato, potato. Well, no, these are two very different things, and we'll explore them in our next installment, Part 2 of 1957's The Atomic Revolution. Or, let me say it this way. The Atomic Revolution. Oh, wait. I've got to warn you. Stay away from that uranium-235. One of those scientists I was talking about had some in his kitchen once, and it got mixed up in his oatmeal. He had such a stomachache.